Okay, 1H. The two triangles S and T are inscribed in a circle, as shown in the diagram below. The triangles have respective areas S and T, and S is smaller triangle such that S is less than T. The smallest value that 4s squared plus t squared over 5st can equal is how many? Okay, so we wish we could differentiate straight away and equal to 0, right? But then there are two variables, so we can't quite do that. So let's see what we can do. Now, for this question, I'm going to go the way that the solution actually goes, all right? Because I think their way is actually pretty smart. So let's follow what they do. Okay, so the idea that they do, which I never thought of, is that they simplify this into 4 over 5 s over t plus 1 over 5 d over s. All right, and what does this equal to? This equals to 4 over 5 s over t plus 1 over 5 also s over t, but now to the power minus 1. All right, this simply comes from the simplification of this fraction here. Yeah, good. Okay, so, and then they made a substitution, which is very clever. So this function is now 4 over 5 u plus 1 over 5 u to the minus 1. Okay, so now we can just differentiate and then, find the minimum value, right? Okay, but then pay attention, because there are restrictions on the value of u. Yeah, there are restrictions on the value of u. So what are the restrictions? First of all, s is less than t, right? If s is less than t, that means that s divided by t is less than 1, right? So therefore u is bounded above by 1. What else do we know? We know that areas are positive numbers, right? If they're positive numbers, then this ratio is bounded below by 0. When the area of S is 0, then so it's bounded below by 0. Okay, so that's why u is between 0 and 1. Good. Okay, so after, if we differentiate this and we put it to 0, and we find that the u we found is not within this range, then we need to think about what the function is doing in between this range. Maybe we have to check the boundaries or something, right? Because we need the maximum in this range. The minimum in this range. Yeah. So if we get a u outside of this range, then that's not what we want. Okay. So let's differentiate. So after differentiating, we get 4 over 5 minus 1 over 5 u to minus 2 equals to 0. All right. Okay. So I'm just going to multiply by 5. So 4 equals 1 over u squared. So u equals, what is this? Okay, can't do maths. Plus or minus 1 over 2. Cool, good. And as I said, the u must be between 0 and 1. Yeah, it must be between 0 and 1. Okay, so question is, okay, do we have to check that is the minimum? Well, I suppose, if the question only asks for the minimum, then you only have one solution, then you can assume that is the minimum, I guess. So, we jam that back in, right? So 4 over 5, 1/2, plus 1 over 5 times 2. Very smart. So 2/5 plus 2/5, which is 4/5. Brilliant question.